The first example of a functional program that I want to give you is that of map. What we will see is that even though each of these functions individually is very simple and doesn't seem to be doing much, together they can become a powerful part of our tool belt as we write functional programs. I've rewritten these slightly and turned each of them into their single line equivalent, but it still does the same thing as I described in the previous video. Now, imagine you have a simple collection of numbers, say 1, 2, 3, and what you want to do is you want to programmatically increment them so that a collection of 1, 2, 3 turns into the collection of 2, 3, 4. This is a very simple problem, and I imagine what comes to mind is the function map. So what I want to do is I want to review the traditional way of writing a map function and then show you and contrast that with the functional way of writing that same function. So to increment each item in this array, we're going to need a function called inc. This is also directly taken from Clojure. Inc simply takes a number and adds 1. Super simple function. And then basically what we want to do is we want to turn the number 1 into the number 2, the number 2 into the number 3, and the number 3 into the number 4. We want to do this programmatically. Now, what you may know is that JavaScript actually has a built-in map function. But we want to write this from scratch to learn how to do it. So what we're going to need to do is write a function map. It's going to take some function that we want to apply to each element, such as inc, and some array. And now traditionally, what you may find yourself doing is writing something like, okay, we're going to have some result array. You prepare some container for your results. And then what you do is you iterate over each item in the collection. And then what you do is you push the result onto the results array. This should be plural results. Let me break this up a bit to make it easier to read. So we can say item is this. And there we go. So we take the current item from the collection, the item that we're currently at in our iteration. We apply the function to it. So if the item is 1 and our function is inc, then that turns into 2. And then we push the number 2 onto our results array. And we do this for every item in the collection that we're given. And then at the very end, we return results. So far, so good. This is a very simple implementation of the map function. And let's make sure that it does what we think it does. So if I call map with inc and 1, 2, 3, there we go. This is what we expected to see. However, this is not the functional way to write this function. One thing you'll notice is that we're doing this in a very sort of imperative or procedural style kind of way because we're iterating here. And this should be a very low-level instruction. We shouldn't really, in a functional program, we shouldn't really find ourselves writing for loops manually like that. It's not idiomatic in functional programming. The other thing is that we're mutating. We have a results array here, and every time we iterate over the collection that we're given, we mutate that results array by pushing the latest result onto it. And mutation is something that we also want to avoid in functional programming because it also makes our programs harder to reason about. So let's see if we can come up with a way to rewrite this whole function in a functional, mutation-free, and loop-free way. So let's call this map old. And let's write a new map function. It has the same signature, so it's going to take a function such as inc or whatever it may be, and a collection. This is again an array. And now first what we're going to do is we're going to check, is our collection empty? And if it is, well then we're just going to return an empty array. Or we can just return the collection itself. It doesn't really matter. But if it's not empty, that means we still have stuff to do. Now what we're going to do is take the first element from the collection. That's going to be the item that we're going to be operating on. And then, very similar to what we did here, we're going to call the function that we're given with that item. Now, this is our result. And then what we're going to do, rather than mutating some array, we're going to recur. We're going to employ recursion. And basically what we're going to do is we're going to return a newly constructed list with our result and a mapping of the same function over the remaining items. This right here is a very common pattern in functional programming, constructing a new list using something like first and rest and employing recursion is very common in functional programming. And so what we do this way is we are iterating implicitly, so to speak, over each item in the collection without writing any low-level loops. Also, we're not mutating anything. We're not preparing some results array that we mutate every time. Instead, we construct a new array every time. So this is all mutation-free. Note that construct does not mutate an array. It creates a new array that happens to contain one new item at the beginning and all the items from an old collection that it was given. So this function is completely pure. It doesn't have any mutations, doesn't have any side effects, nor does it have any side causes. So let's run this function and make sure that it does what we think it does. And there you go. So let's go over it one more time to make sure we understand what's going on here. Map is a function that takes some other function f and an array. The first thing we do is we check if that array, if this collection is empty, because if it is, there's nothing to do anyway, and we might as well stop here and just return an empty array to begin with. This also serves another purpose, namely, later on when we recur, and when we construct this new list and we iterate over the rest of the collection, well, at some point there's going to be a point when there is nothing left in the collection and the rest of the collection is going to evaluate to an empty array. So sooner or later we're going to run into this case. So that's a good way to kill two birds with one stone. And then what we're going to do is very similar to what we did in our original function, which is we're going to take some item, only this time it's always going to be the first one of whatever is passed as the collection. And then we're going to apply our function that we're given to that item. That's going to be our result, same as here. And then what we do is we construct a new array. We're going to stick the result of this iteration at the beginning, and then we're going to do the whole thing over again with the remaining items. And this is going to return our resulting array. And so that way we get a functional, very simple and elegant, I like to think, implementation of map that's pure and in accordance with the functional programming paradigm. And as a result, I think this function is pretty easy to reason about.